All right, everyone. Welcome to Think Data Thursday, Get Hopping with Jumpplot in Tableau. I'm Diego Medrano. I'm one of our community support engineers, and I'm going to be hosting today's event. And we also have our community team assisting as panelists. Before we get started, we actually have a little bit about Makeover Monday with Andy Cockgreave. So I'm going to turn his mic on and give him the ability to speak just for a few minutes about Makeover Monday.
All right, well, thank you very much. This is Andy Cockgreave. Is it possible to share my screen quickly, or is that going to be...
Yep. Let me give you presenter rights.
All right, thank you. Okay, here we go. Well, it's great to be on a Think Data Thursday. For those of you who don't know me, I used to be a customer of Tableau. I downloaded Tableau in 2007 and was very active on the forum for 4 years until they hired me. And unfortunately, since then, I've been less active on the forum. So I miss attending these Think Data Thursdays. But now I'm technical evangelist, and I get to do this project called Makeover Monday, which I'm hoping to encourage some of you to get involved with. I've just added this thread in VizTalk on the community, and Makeover Monday, it's turned into a project where we're reworking charts we find on the web. So we're sharing the data in Excel and Tableau, and it started off as a let's just do data viz, but it's turned into much more than that. So there's a space on VizTalk for you to talk about it. There's a blog post I wrote on gravyanecdote.com, my own blog. It's kind of my manifesto for it. And Makeover Monday is about improving people's data literacy. I think we need to get as many people as we can to understand how charts are made and how we can rework them, and just have a conversation with data. And that's something that has happened over the last 6 weeks that we've done this so far. We're going to be doing it all year, every Monday throughout the year, getting new perspectives on data. Well, how does it work? I'm doing Makeover Monday with Andy Kriebel, with kind of leading this, Andy Kriebel of VizWiz and Zenmaster. So if you go to this page, every Sunday evening or Monday morning, there will be a new data set at the top of this table. Download the Excel file and then have a play with the chart. So for example, this was the original chart we did a couple of weeks ago. It's a fairly innocent-looking dual-axis line chart, but it turned out to be subtly confusing and generated all sorts of conversation. So we make the Excel file available, and then off people go. This incredible screen is the Pinterest board where Andy and I are collecting all the entries to Makeover Monday, and honestly, it's blowing me away what has happened with the community. We've had about 174 people do makeovers in 6 weeks, so that's about 30 a week. And it's honestly, it's just amazing that the community has responded this way. People are trying crazy charts, simple charts. They're sort of learning from what others did and then doing new things on top of that. And it's just amazing seeing the variety of people, not just from the Tableau community. We're seeing things from SAP and some Microsoft ones, and also very much not advanced experts in Tableau. We're seeing new people cutting their teeth and having a go. And honestly, I'm amazed with what's going on. We have the conversation on Twitter, have the conversation on the community, but the conversation is largely on Twitter using the hashtag Makeover Monday. Mostly you're going to see the photos of what people have been doing. Every now and then you'll see people with their makeup or DIY projects, but Twitter is where we're having the conversation. So that's Makeover Monday. It's once a week. Spend about an hour playing with the data, see what you can find or see how you can rework what was the original chart and improve its message. Contribute to VizTalk or on Twitter, or just follow the links and see what other people are doing. And my call to action is that wouldn't it be brilliant if everybody on this talk or on this call today, including Tableau community staff, contributed to Makeover Monday next week and the week after and the week after that. All right.
We actually have a question for you.
Yep.
Dana asks, where do you leave the chart you make? Do you need a blog to post it or Tableau public? I don't know how to put that on Twitter.
Oh, what a great question. I should have answered that. First answer is you open a Twitter account. Right. You don't need to do that. Second answer would be you could add to Makeover Monday on VizTalk. Somehow you need to make Andy and I know you've done it because we are tracking the Twitter conversation. So long as the picture is somewhere online, then we can click this pin it button and we can pin it to the Pinterest board and get it on the Pinterest board. So ideally, you're going to be most involved in the conversation if you open a Twitter account. And it doesn't matter if you only have 1 or 2 followers. But I'm sure we'll find it in the community if that's where you put it.
Perfect. Thanks a lot.
All right. Thank you, everybody. See you on Makeover Monday.
Thanks, Andy. All right. So let me get back to sharing the screen. All right, and so let's hop into it. So as always with Think Data Thursday, we have some housekeeping notes before we get going. So right now you should be able to see everybody who is participating in the event as well as attending. In the chat dialog box, there's a section that says Send To. Scroll down and select All Participants. This is how we keep an open discussion amongst the group. When you send a chat, your name is going to be labeled as the sender. And please keep in mind everyone will be able to see your chat and anyone can feel free to respond. Currently you're all set to the mute position. You'll notice above the chat section and below the participant section there's a little hand icon. Clicking that icon will let me know that you have a comment that's not been addressed. If you'd like to make a comment for the whole group to hear, send a direct chat to host and presenter or all panelists, and we'll go ahead and take you off of mute. So before we jump into it, let me tell you a bit about our presenters. First up is Chris DeMartini. Chris is a highly skilled data analyst and visualization guru with over 10 years of experience in the risk and audit profession. Previously working for Deloitte and now Visa, Chris is viewed as a leader in his field. Chris first implemented JumpPlot and Tableau, proving its efficiency and feasibility and helping build its usage scenarios and applicability in the visualization space at large. Additionally, along with his contributions at Datablick, Chris devised tutorials showing the community how to build JumpPlot using Tableau. In addition to JumpPlot, Chris is focused on incorporating dynamic aspects into his visualizations, including the likes of biofabric, hive plots and circular networks, and even a family tree. His passions for data analytics and all things Tableau have led him to challenge the notion of whether a visualization technique is possible. Chris is just a great resource and one of our Think Data Thursday veterans. We also have Tom VanBuskirk. And Tom is a 10-plus year software industry veteran with experience as an engineer, architect, and executive. A software geek at heart, Tom has a passion for solving real-world problems with simple and elegant software solutions, building sustainable APIs and frameworks, and creating compelling graphical experiences for users. The originator of JumpPlot, while in his current role at Tideworks Technology, Tom was looking to devise a graphical way to visualize repeated event sequences to help marine and rail terminal operators discover and resolve bottlenecks in daily operations. To move JumpPlot past concept phase, Tom joined forces with Chris, who then used his visualization expertise to make JumpPlot a reality. Tom continues to actively seek innovative ways of blending software architecture and user experience to create engaging, efficient, high-quality, powerful software. So with that, we can go ahead and turn this over to, I believe we are starting off with Tom.
Okay, thanks, Diego. Let's see, I need to switch my presentation view here real quick. And
there we go.
All set?
We can't see it yet, but it looks like it's loading. There we go.
Okay. Okay, thanks everyone. This is Tom. I'm going to just get started here with a quick presentation. Promise that we'll get quickly to some of the cool stuff in Tableau and what Chris has been able to do with JumpPlot. I'm just going to talk quickly about the inception of JumpPlot, how it kind of came about, and describe the purpose and utility. And Like most ideas, maybe all ideas, jump plot kind of started with a problem. I work for Tyworks Technology, as Diego mentioned, and we do container terminal logistics and planning and optimization software for marine and rail terminals. And so basically that boils down into the movement and tracking of containers and equipment at facilities, in and out vessel, rail, gate operations. And when optimizing those business processes, we're often faced with measuring success, say, between 2 points. So, for example, we might want to measure gate productivity for truckers showing up at a terminal or their throughput through the gate. And so we might start with a measure asking a question, how long it takes for a trucker to get through the in gate, for example. Quickly, so if we start measuring those things, what we'll often find is that you find some outliers. So very quickly, your measurement kind of turns into a question. What do we do now? Why is it taking so long between these 2 points? So like most analysts, when we get these kinds of variances, we want to figure out why they're occurring. Jump plot really came from this notion of wanting to know more and quickly finding bottlenecks and variances in real-world sequences of events and doing so in kind of a visually compelling fashion. So what do we do when we encounter these situations where you get these bottlenecks and variances? Well, as engineers, we break that problem down frequently. You might add logging or add additional eventing to try to figure out why it might be taking so long in certain scenarios. We might do filters on dimensions or events. In this situation, we can then get an answer to that question of why, for example, one of those flows might be taking so long. And here we see, maybe between our points B and C that we interjected in this process that we have a bottleneck there. The concept of jump plot came from taking this problem where we're measuring things between points and adding a y-axis to that, where your y-axis is your time. And so through doing this, those points, those hops between points become a little bit more graphically appealing. And the other thing that they do is they give you the capability to, effectively add multiple different series of events on top of one another. So now, going back to that original scenario, we can take all of our various measures across these different flows and see where we might have some bottlenecks or outliers in our performance analysis. And so, you can see from this idea that we can find those bottlenecks a lot more quickly, and that it can be pretty visually appealing. And this was essentially the basis of jump plot. So the first thing we kind of did is I didn't know whether something like this existed already, whether we could use something out of the box to be able to do this. So I called up Chris, who's obviously an expert in this field, and Chris being Chris went home and by 11:30 the same day already had kind of prototype together in Tableau for how to do this. So Chris and I kind of started working on the idea a little bit more. We found some plots and charts in the community that are similar, an arc diagram that had kind of done something similar for graphing, but we really didn't find something that was in line with the purpose of this sequential eventing and performance analysis that we were looking to achieve. Following that, we kind of validated the concept. We built a data generator to kind of see how jump plot would respond to some various things, and then came up with some different variances through some thinking about jump plot that you can use that are also kind of visually appealing and have their own purposes within the context of jump plot. So we kind of named it jump plot and put it out there in the community and created a website, and that's kind of how jump plot came about. Some definitions that I want to get into from the outset. This is kind of part of our defining jump plot. The first is a checkpoint. The points, a checkpoint is kind of a point in a sequence of events between which you want to measure. So, one of the things that's somewhat unique about jump plot versus a line chart, for example, is that you really care about the amount of time between 2 points versus the time that you're hitting a certain point. And that's in part what makes these make things fairly easy or intuitive to follow in jump plot. And those lines between 2 points we call hops. So if you hear us referring to hops, that's what we mean by that. Here between B and C, we would call this a bottleneck because effectively across every series of events that you're measuring, you're seeing that this is greater, than other hops between checkpoints. And then you've heard me use the term outliers. These are kind of what we might consider outliers. They're far and away different from what you might see as the norm in a jump plot. And so one of the things that jump plot does is you can kind of see where these outliers exist both on the high side and the low side. So that might give you an indication that you want to drill in further as to what happened because they're outside of your norm. Further, you can see variations or deviations in jump plots fairly quickly. Here you see small deviations between points A and B and D and E. The deviation between max and min and the relative, what you would presume to be the median or average, is fairly similar between these points versus, between B and C and E and F, for example, you see fairly large deviations. So it does give you the capability to see that. The other thing, and frankly Keynote doesn't really do this justice, but Chris will later here in the presentation, is hop aggregation. So when you get a lot of, in a macro view, or when you have a lot of series of events, you might get a lot of lines that are very close together, and you can aggregate those. And that aggregation is not only easier for viewing at times, but it also can be easier, I know, for Tableau to render. And I think Chris is going to mention that as well. And then the other thing is I've always shown here contiguous hops. We talk about sequences of events, but jump plot is also amenable to skipping events. And actually the presentation or the demonstration that Chris will show you will also show that. So you might have discontiguous hops where they actually, for a given series, it skips over a given point. So this is the original jump plot. The basis of the original jump plot was, again, to find bottlenecks and outliers. What we discovered is that the original jump plot's best if you maybe don't have a target threshold, because one of the variations we ultimately came up with after this was a threshold-based jump plot. And this is really a compelling idea, we think, on top of the jump plot, because now you can apply what you think the time amount should be, for example, between your various checkpoints, and those times can differ between those different checkpoints. And so you can see here we've transitioned our axis such that there's a negative axis, and your threshold would be your zero line. Basically y equals 0 in this case. And anything above your thresholds that you're setting will stand out like a sore thumb. And then anything below, I guess similarly will too. So this can be a way mainly to measure your actual performance against your expected performance. And then interestingly, we also thought about an alternative idea for percentage-based threshold or just general jump plot management that gives you normalization. So if you, rather than using, numeric values for time on your axis, on your y-axis, if you switch that over to percentage-based values, then now it doesn't matter the unit of measure that you might use on your between your various checkpoints. So it gives you normalization across a jump plot. Another variation that Chris kind of came up with that is pretty cool is a jump panel. So this is puts things in a trellis view, and Keynote doesn't necessarily do this justice, but what it can do is help you dimensionalize your data and give you some more capabilities for granular analysis for individual series. And this can be, really interesting or compelling, when comparing different dimensions or different series against each other within a dimension, or doing filters and that kind of thing. And and then one more thing that I really couldn't show easily in the webinar today, because frankly Keynote doesn't do a great job with showing it off, but is jump lines. So this is a new idea that Chris is going to show off as well today. It's interesting for seeing jump plot along with the other data elements that you might want to see in a grid fashion. So very, very cool. So, we obviously like jump plot. We think it's kind of cool. Certainly interested in feedback and how people might want to use it, or different ideas. For us, what we've found is that it's beneficial for sequential eventing. And one of the things that comes along with that is because, our perception of time as humans is in a linear fashion. It tends to lend very well to real-world analysis. Additionally, some use cases we've thought about is, there's a microservices movement in architecture where we're breaking down software architectures into more smaller services in the middle tier. And as you do that, you introduce additional hops, if you think about things that way, between various software elements in your software architecture. And so measuring things, the delay between those points and how long those various microservices are taking for their operations and the overall flow of applications is kind of a compelling concept as well. Obviously, we kind of showed off that, we think things are fairly visually appealing with regard to outliers and bottlenecks, that they show up easily and well in a jump plot diagram, and that threshold breach is it seems to be a good use case for jump plot as well. So why use it? It's fairly intuitive to the eye. We've gotten some really nice feedback from the community after posting this, that people find it intuitive and are taking it to various folks in their organization and saying, hey, what do you think you see here? And they're seeing some of the things that they're supposed to see right at the outset. We think it's pretty visually appealing. It scales well to multiple series. It can scale well to checkpoints up to a certain point, and I think Chris will show off that. And then, we have a variety of variations that you can use on top of it that help you solve different problems based upon the problem space that you're looking to solve. So certainly interested in your feedback, and now we're going to get into some of the cool stuff with Chris. So this is as a precursor to that. The data generation built for this is for a scenario where we might be looking at Atlassian, kind of had Atlassian on the brain when doing this with their various product offerings. So the scenario that we have here is based upon their products. And the way that Chris and I go about doing these data generations and analysis is that the data is generated, and then Chris uses Tableau to to analyze this in kind of a double-blind fashion. So he doesn't quite know what he's looking for, and he's seeking those things. So it's kind of cool to see him put together the dashboards and whatnot to be able to find some of the things that are introduced as permutations and variances in the data as it progresses. So, we'll get into more detail here, but I think I'll hand it off here now to Chris.
Perfect. Let me go ahead and make sure that he is a presenter. There we go. Awesome. Thanks a lot, Tom.
Okay, so everybody can hear me and see my screen okay right now, right?
Yep.
Okay, perfect. So Tom, thanks for the run through. He really focused on the why and the what with regards to the graph type. What is it that we're trying to solve for? Why are we doing things in the way we're doing them? So on and so forth. So the last point that he talked about, so with the data generation that he did for these examples we're going to run through today, we were trying to talk about what would be a good thing to show on the webinar today. And one of the pieces that we were kicking around is whether it would make sense to try and do something around the software development lifecycle. And I went on Google actually while we were talking about it and went to look for anything that might be out there in terms of existing dashboards. So if you go to Google and you type in, let's just do SDLC. Nobody wants to watch me type all that. Type in software dashboard, go to images, and there's a lot of not so great looking stuff out there, right? So you got your 3D pie charts and this and that, and really, as we researched it more, we really had trouble finding kind of anything of use out there, and so we thought it might be a good example to run through in today's webinar. So what I tried to do is use the data that Tom generated. He did put some anomalies and things like that in the data, which I don't think he gave himself justice on how he did all that. We could probably spend an hour just talking about how he went about doing that to make some meaningful data that we can try and visualize here. But I got the data from him, and basically the goal that I had was to go through and visualize the information and try to identify where those bottlenecks that he's inserted into the process were. So we have here a top-down set of dashboards that we built. This is really based on the use case we've been talking about. And what we wanted to do was basically test out for ourselves, but also see where JumpPlot was able to add value and where maybe it didn't. And so our process as a whole, for starters, you can see what our process looks like. We have, 9 hops, 9 checkpoints in our process. We have some cases where you may or may not hit a checkpoint as you go. And we also have a step in the process that's actually moving backwards. So that's basically how the data that Tom put together looks. And this view here that you're specifically looking at is for, kind of the higher level individual. This would be for somebody who's in charge of maybe the whole process, the whole team, the whole region, whatever the case may be. And we have a view where you kind of get your high level numbers right off the bat, so you know where your 25th median and 75th percentiles are, what the change of that was from the last time. That's just mocked up for now, but theoretically you would do that. And then on the left here we have a bar, and one of the things that I noticed as I built this was this bar on the left is total time for now, but if you look at the dimension that I'm using there, it's actually the hop, right? So for example, this bar here in 1.2 is the same as this hop here. And one of the things I realized, granted I did sort it here, but even if you did sort it along with the order of the checkpoints in the sequence, I wasn't really sure, like where to put 6.3 and does 5, 6, or 5, 7 go first. And so there's some of that sequencing that gets a little convoluted when you have things like discontiguous hops that Tom talked about. So that's one of the things right off the bat where I felt like having JumpPlot allowed you to stay in the sequence while you're analyzing the duration between each step. Also added some other, high-level information here around, products. Maybe they want to look at the products to see what the distribution of the product looks like from a time perspective, and then also where was our biggest outlier. So this view is using an aggregate. Well, it's an averaged jump plot, not really an aggregated jump plot in terms of our variation that we build. But this is specifically just one aggregated view of all the information that's showing the average hop time between each hop. So the math isn't too convoluted there. It's basically just aggregating up an average. And the reason why I did that is because if this is going to somebody who's higher up in the organization, and if we put the entire distributed plot in front of them the first time they look at it, I think it would be a little bit of too much information. So this is really meant to be at a high level. Can you look at whether you're doing better or worse than you were the last time you looked at the screen? Can you tell where issues may lie that you need to ask people under you about, and so on and so forth. So this view really built around that. And then from there, either the same individual can drill into the second view, or a person who's in charge of managing, maybe the teams or the products or whatever the case may be, can utilize this. And so this second view is really built around trying to get into more of the detail. So going back to the fact that I didn't know what was in the data Tom sent me real quick, you can tell here that we have, quite a bottleneck in terms of the development phase of the process. You can also tell, for example, it's a little more intricate, but you can tell that when we do testing, when it fails, we're slightly elevated and then it passes. So that's a very small difference, but you can at least answer that question of, does it take more time to test when we fail or when we pass? You can also see it seems to be taking a while to get back into development after we have completed our testing and that's failed. I'm not sure why it would take so long to get back into development, but those are some of the things that you can see at a high level with the visualization. So jumping back into this view is really more at the dimension level, and you're looking here for the next level down in terms of the data. And so we know at a high level, for example, that the development hop is becoming an issue, and we know we have some time being spent going backwards, and that we normally see that the testing failure taking longer than the testing completion, and that kind of holds true here as we drill into the detail of each one. And so the other thing that we wanted to do was, show some actual numbers along with it, not just the plot itself. So we did things like we added the hop label in, and so that's what you can see here in the plot. You can see that we have 24.45 median or average hours in the development stage for ostriches, right? And that brings me to the point of the team names, and I'm not sure where Tom got the team names from. I think he went and got them from the fastest animals on the earth or something like that, off a wiki or something. And so it was interesting because we have all these development terms and then a bunch of animals for team names. But anyways, I forget which one was the fastest, but we were joking around that. It was interesting if they all ended up being in the order that they were in terms of fastest animal. But what we wanted to do here is show, while Marlin has the largest amount of time in its total, and it also has the largest amount of median time, which is sorted here, you can tell where they're running into problems in the sequence, right? So that is something that I think we were able to get out of the jump plot in terms of this analysis. And, Tableau is so powerful that you do that not only for team, but for product and for region, and you can create all these great interactions between the different pieces of the dashboard. So it's really easy to discern, what you're looking at in cases where you have multiple pieces of data on the same screen. So from here, the next question would be, why is this product or this team the outlier at this level, right? So you're going to continue to drill as you work through the dashboard and try to answer your questions. So I'll go back to team for now. And as you drill, let's say we want to look at this one, right? So we know Marlins is having some trouble, and kangaroos are as well. But we want to take a look at ostriches and see what's going on there. And so we can actually drill even straight off the jump plot into the next level down. And so this is a view where you're really getting more granular now, and you're taking a look at what may be causing some of the inefficiency at the higher level. And so here we're looking for, is it something where, there's bad requirements coming through, or whatever the case may be that's causing pieces of the process to take longer than it should. And so this introduces that concept that Tom was talking about with respect to jump line, which is like an inline version of jump plot, kind of like a spark line was the initial inspiration for it. And I think it can be pretty valuable, just like a spark line can be very valuable to the user if done right. And it allows you to see not only, kind of the high level numbers, but the distribution of those numbers across your series or your sequence. So I think it does add value. Obviously, like Tom mentioned, we're definitely open to people's feedback and like to hear what you think. So as we drill into ostriches here, you can tell that this individual here is taking 112 hours to do development, and their hop for the development phase is an average of 36 hours, and their hop for the test failure phase, I think that one is 24 hours. So a lot of data can be gleaned from this. And one of the concepts I added to the jump line on the right is actually the average hop across the population, right? So I tried to, I think I maybe needed to use a lighter gray, honestly, but I tried to use a really light shade to just put that in the background of the jump line in order to help you determine what that measure is. So you can go back and look at various teams. So here we drill into kangaroos, and you can see the same information there. You can flip between the different individuals that are responsible for getting through the development cycle and see if we have any outliers in terms of that. You could also just come straight into this page and let me take this filter off. Come straight into that page and take a look at how everybody's doing overall, right? So it doesn't need to be filtered necessarily. That's just something you can do if you're looking for a specific answer. So that at a high level is the view that we built out. I think the answer to Tom's question that he was asking of me is the fact that your development phase and your testing failure phase are probably your two worst areas. The teams that are struggling the most are the marlins and the kangaroos, and as we drill through each of these, you can see that there's some cases where a team that's further down, they have more anomaly of a hop for them throughout the process. So an interesting use case. I hope you guys find the dashboard useful in terms of, if nothing else, just some ideas of how you might go about visualizing time through these sequences. One thing we did do as well is we did do just like a full-blown distribution plot for, let me put a valuable value in there, for the data. And so this would be, like if you did end up drilling in further on that last dashboard we have. And so this is the very detailed, every single hop is rendered. And you can tell, at any point which item was the most trouble for a specific process, right? So here's the actual sequence. Here's the, obviously, full tip sequence, but here's the in testing complete sequence, and it took this much time, and so on and so forth, right? And so as you switch that between the testers, and this is something where, like, if you were to put all this on a screen in like a trellis view, that's where like the jump panel would potentially help you visualize across all your testers what the detailed distribution view looks like. I would keep that separate from something like this where you're just trying to get over at a high level, this is how they look overall. This is much more granular in terms of data and in terms of the ability for you to consume the data. You wouldn't want to squish all this together in one little space like we did with the jump line. So that's at a high level what we did with that dashboard. I'm actually going to have it on my Tableau public page following this session today, and so you could go in there and play around with it, and love to hear people's feedback and whether or not you think it's a valid use case or a visualization in terms of the use case that we were trying to solve for. So From there, I did a little bit more playing around, and I'll just go through this quickly so we have some time to actually build a jump plot here. So I was in our original creation of the graph type. We did some work with home run data from the MLB, and so here's the source here. And we were looking at how long it took for people to hit home runs, like how many days elapsed between home run 1 and home run 2. And the thought there was you'd be able to identify hitter slumps as you go. And so we took some time and downloaded that, and that's an example of using jump plot without a discontiguous hop, right? So here we have the concept of discontiguous hops, like this one goes to here and this one goes to here. With home runs, you either hit your second home run or you don't. There's no question of contiguous or discontiguous. So I was playing around with it. I think it's kind of interesting if you actually use a polygon in Tableau to do it. And the one issue with that, though, is then you run into more overplotting. So you have to be careful when doing that. But gives it an interesting look worth playing around with. And with the continuous hop, what I wanted to show was you could use, a line jump plot. You can use polygon. You can use bars, frankly. You could use dots, right? And so with the dot plot, you get the same information when it's a contiguous hop series, right? So that's pretty much the same as that. And so that's really where it's up to you all as you're developing to choose which view is really the most meaningful for what you're trying to do. And it may sometimes be the jump plot, and it may sometimes not. That's where the designer, the person doing the visualization, needs to make the right call. A couple of more examples of the jump line concept that Tom talked about. And so we took that same home run data, and what we're looking for here is basically just kind of a detailed view into a Major League Baseball player's power numbers, right? So this is for the 2015 season, and you can see, for example, Chris Davis hit 47 home runs. You can see his average and maximum speed off the bat. Again, all this data came from the reference here, which is really a rich set of data if you're dealing with home runs in Major League Baseball. And on the right, we added the jump line concept to the data here. And there's two things that I was kind of pleasantly surprised about with the jump line when I put it in place here is one, I actually think you can, pretty reasonably tell the variation as you go across the line here. Just like with a spark line, you can get so much information out of a spark line. It's a very valuable technique. And so I was kind of hoping that would be the case, but I was happy to see that came true. And the other thing, which is kind of like an added bonus for me, is it actually kind of works like a bar chart at the end of the day. I mean, I have, not necessarily the same number of home runs on each of these, right? So this one has 47, this one has 44, this one has 41. The length of the jump line actually responds to that number, right? So it kind of serves twofold for me. I do think, obviously, if you're just looking for analyzing the total number, obviously a bar is the way to go. I'm not going to argue that by any means, but if you're trying to kind of do two things at once, it may be, reasonable to take a shot at that. So interesting, if nothing else, it was fun for me to implement. I also added some color to the hop so you could tell, that this hop is 18, this hop is 22, without really having to mouse over and do those sorts of things. So I think that the jump line can add value, like in an inline situation like this. But then, obviously, when you're looking at, high level, this is basically a jump line at the end of the day too. It's just, much, much higher level and larger than an inline version of it, which you see here. So with that being said, we have about, 10 minutes or so. We'll try and actually go through the process of creating a jump plot in Tableau. And what I'm going to do for that is I have a set of data, and I'm going to run through this pretty quickly here, but we basically, a lot of times when you're working with event data, you might get something like this that has the data on one line, and everybody knows when you're working with paths in Tableau that you need to have two lines. And so what I'm going to do is I'm going to grab this data and I'm going to do some quick prep work on it in Excel, just so it's easy to understand what I'm doing. With respect to tools to use to do this sort of thing, You can try and do as much of this as you want in Tableau, but other tools like SQL or Alteryx are also pretty useful for automating this type of process. I've done some of that, at work where I've been able to, fully automate all the data prep and everything. The jump plots created and updated on its own without really any intervention by me along the way. So the first thing I'm going to do here is create a path field, which is the unique identifier for this combination. So I'm going to create this plot at the level of region, team, product, and then I'm grabbing where it started and where it stopped, right? So each hop in 3 dimensions that I'm analyzing, I'm going to go ahead and copy that down. For the path order, basically that's going to go from 1 to 2. So for the first set of data that we're going to create, we're just going to make that equal to 1. And here in the event sequence, we're going to set that equal to whichever node we're currently on. So when the path order is 1, we're going to pull the start, and when the path order is 2, we're going to pull the end. And we're going to do the same thing for the event type. Do that real quick. All right. So there is our key elements that we want to bring into Tableau. I'm going to copy that down, and so now we have one copy of the data that's set up to be basically path 1, and so we need to duplicate that and make it path 2. I'm going to copy that, put it down here. We're going to change this to path 2. Obviously, you would do this programmatically in the real world. Delete this extra line. And then I always like to sort it to make sure what I did made sense. So I'll just go ahead and do a sort of that. Okay. And so here we have basically each hop ready to go for Tableau. You have, starting from 1, you go to 2, and your path order is 1 to 2, 2 to 3, path order is 1 to 2, and so on. With jump plot, like one difference from other path data that you might work with is you actually end up with only one record for the start and end of each sequence, right? So you're going to have 2 records throughout the sequence, but from the start to the end of the sequence, you're going to have 1 record. And so that is something to keep in mind as you're preparing the data for jump plot. And the way that works with the first one is it has to be the first step in path order 1. If it's the first step in path order 2, you remove it, and the last one would be the last step in path order 2, and if it's last step path order 1, you'd remove that from your data as well. So I'm going to save this, hopping to Tableau here, sheet, and I'm just going to bring that in. I turned off those. Okay. Yeah, this. All right, so now we've got our data. Do a quick extract on that. And what we're going to do now is we're going to start bringing over some of the formulas I have from my examples that I've done just to make sure we can get through this. So the first thing we're going to copy over is the Bezier value, and this goes back to some of the initial work I did on like network graphic in terms of implementing Bezier curves in Tableau. The hop that you're looking at in the jump plot is the Bezier curve at the end of the day. So really here we're just setting up the numbers that you need in order to drive the Bezier curve as it goes from basically 0 to 100%. So we're doing some legwork there. We're going to create bins off of that. So there's our bin, and from there we're going to take T and index, the next 2 that we're going to copy over. And so T is based off of index, but it's basically index minus 1 divided by 100. And index is just an index running along the path in bin. Now the reason why you need index is because you cannot use the bin field as a numerical measure as you go. And so you actually have to bin and then create an index off the bin in order to be able to use that. But if I add these in, let me filter off one path real quick. If I add index, that'll be the running number. If I add T, That's basically the percentage as you go from 1 to 100. So next we're going to pull over our time. So let's grab hours and checkpoint and hop. So these are, so checkpoints just basically set to event sequence number, which is your checkpoint number as you go through the sequence. In this example that I'm showing you, that's just a numeric number from 1 to 9. So I don't have to deal with any, weird sorting or anything like that. You might have some of that in your real-world data that you'd have to deal with. And then hours elapsed is basically just our time. The total number is actually in minutes, so I'm just dividing it by 60, and I'm using a window function to copy that down. So if I were to pull total over versus hours, you will see that my total only has data here, and my hours will have data across the whole population. So pulling that stuff in, and then next we're going to grab curve. So curve X and curve Y, if you are using my workbook as a starting point to get your own jump plot going, are going to be basically your X and Y coordinates of your checkpoint, right? So from an X perspective, each checkpoint number is going to drive where it is on the axis, and from a Y perspective, everything's going to fit on the Y axis, which is 0. So that's your coordinates, and if you were to modify any of these, it would modify where your checkpoints are in relation to your graph. So that's what the purpose of those two are. And then we're also going to grab these down here. And all these do, the XP min and max, is I'll just show you one of those. So basically, from the min, you're taking your first coordinate and copying it down the data, right? So window min curve X first is going to grab whatever the first value is for your windowed function, which is for each path. And you're going to copy down that coordinate across the data. And the max is the exact same thing, except it's looking at the last set of data. And so that's going to pull your coordinates up and down across your data set in order to apply those throughout the equation of the curve. And two more things, and then we'll start dragging hills. All right, so we're going to copy your oh yeah, all right, so enum, secnonum, those are also needed. They have the checkpoint number copied down as well. So that is the starting node, and secnonum is the ending node. So that's all that does. And then now, once we've done that, we can use these dynamic midpoints. And this is really where you're able to create the hop. So this is the control point for the hop that we're starting to put together in the coordinates for that. You have basically the distance, halfway of the distance between the first and second point is the calculation here. And Y is set up to your time measure. So this is where you're actually putting the time measure on the hop. You have to multiply that by 2 because of the math of the curve equation. And then here I'm actually doing an additional step to say if you're going backwards in the sequence, make it negative. So that's all specific to the data that I'm using here, so you may have some variations of what needs to be there. Let me go ahead and copy over the curve equations. And so these curve equations, again, I've talked about them a couple times. The wiki page for the Bezier curve has great details on how to go about this, but basically you're starting from the first coordinate, you're moving along towards your dynamic control point that we just talked about a minute ago, and you're moving towards the second point in your node. So, okay, so we're ready to create a jump plot here. So let me go ahead and drag this path, drag that path, or detail, sorry, not path, detail. We're going to put X on columns, Y on rows. And so that issue is that I did not do this. Let me put that back. And there you go. So from here, always put the bin value on there. In terms of formatting, I like to keep the view with the jump plot pretty clean. I like to just maybe have the one axis over here, so I would hide this. You'd rename this axis to be, elapsed time, average time, whatever measure it is that you're using to build the plot. We can use, various things to do the color. We use all three of these measures in the plot itself, so any one of those can be used to highlight. Definitely not that difficult to do in Tableau. I mean, it's one of the powers of Tableau to be able to do all this, in the 10 minutes that I had here at the end of the session. Once you have a template like this in place, it's really a question of getting things organized correctly and copying and pasting fields. And the last thing I was going to do is I actually was playing around with, like how we animated some of that stuff in Keynote, and I was thinking we should be able to do that in Tableau. And we should be able to do it on Tableau Public too, hint, hint. But the act of moving that along, and so you can use the path shelf actually to do that animation as you go, and watch your jump plot grow across your dimensions. You could use index and actually watch the plot go over time. So if we move index on there real quick, and then if you go from here, so it actually goes from the start. So playing around with it a little bit. I didn't get to as much of the playing around as I wanted to, but at least hopefully today you got a better understanding of the jump plot, of the purpose of the jump plot, what it's good at, when you need it, when you maybe don't need it, and hopefully you find it useful for some of your real life use cases. So with that, Diego, I'll pass it back to you, and I don't know if we're kind of right up on time. So if there is maybe like one question, we could do that.
Yeah, let's see. Evan said, great stuff. I guess it's not really a question, but he said, I would be interested in seeing it compared to a Gantt chart for planning / analysis, or I will go do that myself. Cheers. But it looks like we might have other questions. So Kevin said, thank you, this is amazing work. You mentioned that building an average or aggregate jump plot is relatively easy. Can you quickly review how that's done? I'm struggling with it. That is, if I have 1,000 series and I want to aggregate them all.
Right. So the way I've done the aggregation piece, all right. So the way I've done the aggregation piece is, let's say you have 1,000 series and you want to aggregate those just because of the rendering time of Tableau is taking too long or something like that. What I've actually done is aggregated it based on the amount of time between each checkpoint of the series. And what that allows you to do is, let's say you have for jump 2 to 3 in your sequence, you have maybe 100 distinct times that took place between A and B. And you might have to do a little bit of aggregation there, because if your data is at like the millisecond, that's not very likely. Maybe you've aggregated up to the minute or something like that. But what you can do is then take all those unique time that happens between A and B and aggregate it to that in order to count and total the transactions that took place within those times, right? So that is one way I've gone about doing that. Definitely feel free to reach out to me. I'm actually about to get kicked out of my room here, so I got to wrap up. But feel free to reach out to me on Twitter. I can do a little bit more justice to what you're trying to do. But I have automated a process where you can do that aggregation for whatever data set it is, and it'll aggregate the hops based on the amount of time in between each of those. So each of your paths basically would be, hop 1 to hop 2, 25 seconds or something like that. And that would aggregate everything that done those 25 seconds. Okay? So, Diego, I'm actually getting kicked out.
Yeah, we can let you get going. So,
yeah.
Thanks a lot, Chris and Tom. So this event will be posted online in just a few hours on the community. Likewise, you can feel free to ask any questions there. We can also forward along any questions to Chris or Tom and make sure that it gets in front of their eyes. So, as always, we're open to any feedback, questions, ideas for future Think Data Thursdays. So feel free to email community@tableau.com or post in the community canvas, and we'll get back to you. So thank you to everybody who presented today, and thanks for all the attendees as well. Have a great day, everyone.
Thanks, Diego.